We are live. Okay, I think we are live. Okay. Hello all, and I would like to welcome you. Okay. So, welcome all. Welcome to the YouTube live at Fire Lily High School. And this week's topic is predicting fraud transactions. All right. So now, predicting fraud transactions. Let's understand why is it important. So, whenever you will be working, maybe if you're working in a bank, you'll be knowing that there are several transactions that that can be termed as fraud, and time to time they keep on happening. People try to launder the money or try to steal someone else's money, and this is a very common practice all over the world. And it's very important to predict such kinds of activities for especially for banks, because whatever happens, if there's any kind of what you can say, any discrepancy that happened with someone's money, the first and foremost uh, institution to be blamed is a bank, right? So whenever if you have an account and some amount of money is taken away from your bank account, so first of all, you would be blaming the bank for it. So it is most important for someone who's working in a bank to predict such fraud transactions and stop them from happening. Right. So whenever there will be any transaction, if the algorithm flags it as fraud, it won't happen. The transaction won't take place. It will stop the transaction and it will try to validate it. So usually it happens. Sometimes if you do a transaction and it somehow it's not able to transact, the app will be blocked for 24 hours. Either it will be blocked for 24 hours, or it will ask you for an OTP, or it will ask you for some or the other thing which will identify you as you, and will also allow you to make the transaction. All right. So, but for that, the first thing that we need to do is to flag that transaction as fraudulent. And for that, we need to create a machine learning algorithm which can help us in flagging it as a fraudulent transaction. So I went to Kaggle and tried to find out any data set that would help us create this machine learning algorithm. So there was one data set named as bank transaction data.csv. I've saved it in this system and I have tried to import it. So first of all, let's let me restart the kernel once again. So okay, let me see. This is Mac. I'm new to Mac, so usually I'm not able to work on Mac. So let me see how do I think restart session. So okay, all right. Now the first thing that we do is to import pandas as speed, and then we can import the data set via this. So you can see that this is the data set that is that we'll be using for the machine learning model. Now let me save it. Let me save it as df, df, which means data frame. All right. So now we have stated the problem. The problem is that we need to create a machine learning model that will help us predict the fraudulent transactions. Now the next step is to collect the data, which we have done. And now comes the next step is to clean the data or to explore the data, right? So we call it as exploratory data analysis. Let's start with exploring the data a bit. Let me see the first few rows and how it looks. So this is basically how it looks. It has several columns. I guess okay. I don't know how many columns or rows we have. Let's see. We have dot shape will tell me how much columns and data sets or data points we have. So we have 2512 rows and 16 columns. Alright. There are a lot of columns and there are a lot of rows. 2512 rows. The first is transaction ID, then it comes account ID, transaction amount, transaction date, transaction type, basically location, at what location this transaction took place, the device that the transaction took place with, the IP address, merchant ID, the channel, customer age, customer occupation, transaction duration, login attempts, account balance, previous transaction date, and such kind of data. We are having this data set. Now, what we'll be doing is we'll try to drop a few columns. We will not start with dropping the columns yet. We'll try to explore the data again. We'll try to explore the data, what kind of data this is, and what kind of columns will be needed for our modeling, and which ones that we can drop. All right, so it's clear that we need to. Okay. So I'm trying to find out my target variable. This should be a flag. So maybe it's possible I'm not able to see all the columns over here. Let me see. Here, dot columns. Okay, so these are all the columns in the data set. Wait, transaction duration, account balance, previous transaction date, login attempts, channel, customer age, customer occupation, IP address, transaction type. So I don't see it as flagged somewhere. So let me see this is flagged somewhere. So again, because we want to perform a supervised machine learning algorithm, I cannot see any flagged, flagged column over here. So I think this won't be we won't be able to perform machine learning or we are using this data. We have to select this different data. So let me see on CADA. Let's go to CADA and data sets. Let's try to get a new data set. All right, so let me see another, bank transaction data set if I could. So please be patient with this. Just trying to download another data set for fraud detection. Huge data, 37 MB of data. So again, got that. Found out one data which is very huge data set. So transaction data, fraud analysis, trying to find out different type of data which can help us. So I see one over here should be able to go financial data. So no, again, transaction ID. Okay. So I got the data that I wanted. It's somewhere around 1.0 MBs. Uh, if you also want to download this, I'll tell you on Kaggle it's named as transaction data for fraud analysis. It's uploaded by someone named as is a is a Bagel. So ISABBAGGIL. So I downloaded the data. Let me upload that data over here. Let me download it. Give me a moment. Alright, so I've downloaded this data. What I'll do is copy the path. Let's change our data to this. Let's change our data to this. Let me delete this real quick. Let me copy paste this thing over here. Let's run the new data set. Now you can see this is the new data set that we have. You can see help us, flag if our what you can say if our transaction is fraudulent or not, and we will able to classify our data set according to that. So let's see how much shape does this data set have now. Okay, it has 11 columns and it has 10,000 different rows. Alright, these are the various column names that this one has. Now let's try to see what kind of data do I have. So info. Let's see what kind of data do I have. I can see that I have various data sets such as I have ints, I have floats, and I have objects. I have two objects. I have two objects and I have four ints and one float. Five ints and one float. I have more than two objects. I have one, two, five objects. All right. So okay. So let's try to see. Now I know there are no null values. I don't have to worry about the null values. I don't to delete or include the null values. So I'm safe over there. Now what I have to look for all the numerical continuous variables for the outlier treatment. So let me see. Df dot head. And let me see how many you know numerical continuous variables do we have here. Okay, but before that, we can downright delete a few columns. So I'm pretty sure transaction ID should have no relation with it being fraudulent or not. So I'm pretty sure I can drop transaction ID. But customer ID and merchant ID, I'll keep it for now. Transaction time, I would delete it because that would make this as a time series analysis, and that would call for some advanced model. So I will just delete the transaction time as well. Then amount I can keep. And then card type is important. Location is also important. Purchase category is also important. Customer age is kind of important. Let's see how it helps. And transaction description would also be not of use for us. So let's start by dropping this value. So df dot drop. Let's pass a list over here. The list of all the funds that we want to create. What I'll do is I'll use a technique. So let me create a new cell over here. df dot columns. df dot columns. Now I'll see what all columns I want to you know I want to drop, and I'll select those columns over here. So I want to draw transaction ID which comes to zeroth column, then comes 1, 2, 3, 4. So fourth column, then comes 5, 6, 7, 8, 9, and 10. So I would also have to delete the 10th column. So these three columns that I need to drop. Let me see once again. Right. So these are the three columns that I need to drop. So what I'll do is I'll just plainly write it like this, copy this, and write it in here in the list form. And if I run this, you'll see it drops. Okay, not found an axis. Right. So always remember to mention the axis from where you want to drop. So axis equals to 1. If you run this, you will see again. So we have not found an axis. So what I need to do again is I will have to remove this extra. Now I guess it will work. So now you see all the ones that we didn't want has been dropped from our data frame. And I'll just save this as a new PSO. So I'll just save this as the new or input this as the input to our previous data. So now our new data becomes this. This is our new data set, right? And alright. So what I'll do is next is I'll see if we have any outliers. So what are the numerical continuous variables that we need to check the outliers for? The first is amount. Amount is a continuous variable. Then comes customer age. So we just have two continuous variables that we need to work upon. So let's see. But in order for me to check if it has outliers or not, I would have to first create a box plot. So let me first input all the libraries that I'll be needing. Let me import NumPy, then let me import Seaborn, and let me import my plotlet. Okay, so when I run it, this is all going to be imported. Now let me plot a box plot. So sm.box plot, and that you can see. Okay, so there are no outliers in our data set, so we don't have to worry about the outliers either. But we can definitely see that this amount is scaled up much higher. This is scaled up much higher. So what we'll be needing to do is we need to scale down this amount column as well as the customer age column, because even though because I have a bit of experience in this, I can see that this is slightly above zero. And we know that customer age ranges from somewhere around 20 60 kind of thing. So definitely when I scale this down to 0, the things will change. So let me import my scaling. So from scalar dot preprocessing import, let us try to solve it by min max scalar. Min max scalar ms equals to min max scalar. Let's create an instance for this object or for this class. So now what we'll do is we'll try to fit and transform this fit underscore transform the variables that we need to scale. So I need to scale these two variables, so I'll write both of them over here. First is amount and second is customer age. So customer underscore age. Okay, so if I run this, you'll see this will create this into the required form. Now what I'll do is I'll copy this. and paste this over here and input it. So you can see this will be changed in the original tone. When we try to when we try to what can say when we try to plot the box plot once again, you'll see these two will be scaled. So amount and customer age have been scaled down. Now again, because these are in the ranges like this, we also need to scale this down back to zero. So customer ID and merchant ID. So I'll repeat this process. I'll just copy this code and write it down over here. So I'll add instead of amount, so this is Windows, so in that one box over here, so customer ID. Here I'll write say customer ID. Customer age I will replace with merchant ID. And similarly, merchant ID over here. And if I run it, it will work the same and scale the scale down the these two variables. So now if I run this box plot thing, you'll see that all of these are now in considerable range, and we'll be able to we can easily now work on this. Okay, so now I think we might be needing to do a transformation because these look like mostly they are normally distributed. But let's see the skew value. So df dot skew numeric only equals to 2. That's it. Think so. The skew values expression cannot contain assignment for achievement numeric underscore. Okay. Okay. So I think that's something else for this. Okay. Numeric. So I'm not sure how. If I run this, I'll see these key values are almost near to zero. So I don't need to perform transformations on it. This is already normally distributed, almost normally distributed. So this is good to go for this thing. Now the last step that's been remaining is to convert the categorical variables into numerical ones. So we see we have the this is not the correct data set. Let me see the correct data set. So this is our new data set. We have this card type, location, and purchase category. So we need to handle these three categories. And I can see that all of these are most. Let's see all the unique values in this case. Card type, location, and purchase category. So let me see df of card underscore type. What was the next? Location purchase category. Dot unique. Let us see how many unique values do they have. Card type location not an index. Okay, makes sense. Because I forgot to add code over here. Okay, so I would have to look at them individually. Let us see how many of these have unique values. So this has 1, 2, 3, and 4 unique values. Then comes location. I think it will have a lot of unique values. Yeah. This has a lot of unique values. And then comes location, and then after location we have purchase category. Alright, so this has again around six categories. So what we'll do is we'll use label input for all of them. So from uh, sklearn dot preprocessing import label encoder le dot label le equals to, we need to create an instance here over here, label encoder, right, le dot fit. So okay, what I need to do is I need to do it for this three, what we can say, three categories. So what I'll do is I'll, instead of taking the longer route, I'll just write a for loop and perform this for all the three at once. So let me see, df dot columns, df dot columns. So what I want is card type, location, and purchase category, which is I think 0, 1, 2, 3, 4. So what I'll do is 4 till 8. Let me see. My bad again. 4 till 7. So I need to perform this label inputting on these three columns. So what I need to do is for I in this, for I in this three columns, um, df of I equals to le dot fit underscore transform, and this I pass df of in. And if I run this, you'll see all of this would be performed at once. If you see df dot head now we have all the data in numerical format, which is now ready for our machine learning process. So the next step that we will do over here is to label the data set. Now we'll have to label which are my inputs and which are my outputs, because we are performing supervised machine learning algorithm, and that's why we need to label our data. So let me label capital X as my input variables. So what I want to do is I want to select all of them except is fraudulent to be my input variable. So X is df dot drop. I'll drop is underscore fraudulent. I'll drop this, and whatever is remaining will be my input variable. So drop it from X is equals to 1. The rest will be my input variables, and my Y will be my df of is fraudulent. Is fraudulent. Run this. My data has been labeled now. I've labeled the data in terms of inputs and outputs. Next thing that I'll be doing now is to split the data set. I'll split the data set into training and testing data sets. And for that, we need to import train test split from model selection module in sklearn. So from sklearn dot model selection import train test and split. Alright, so we do this, we import train test split. Now, what I'll do is use train test and split on capital X comma small y with a test size of around, let's say, 0.2 for now, and random state variable 0. Alright, if I do this, you'll see this X and Y, our input and output, has been split into 4 different arrays. And these 4 arrays are basically the training and testing inputs and training and testing outputs. So we'll also save them in the variable. Let's name them X train, comma X test, comma Y train, comma Y test. Let's save them in this variables. Now, since now they are saved in this variables, the next thing we'll do is select our model. So now this is a classification kind of problem, right? This is a classification problem. So what we would have to do is we would have to classify them, right? Classify them as maybe fraudulent or not fraudulent. And for that, we'll need to perform a classification kind of problem, or we'll need classification ML algorithms. So there are several, classification algorithms. There's logistic regression, there's k nearest neighbor, there's SVM, there's knife base, there's decision tree, random forest, and so on. There are a lot. There's gradient boosting and so on. So there are a lot of ways. But let's try to use some basic kind of you know classification model to start with. So let's start with the logistic regression. So in order for me to perform logistic regression, I would have to import the model from the model called as linear model. So from sklearn dot linear underscore model import logistic regression. Import logistic regression. Let's create a model, or sorry, let's create an object or an instance logistic regression. Again, because in logistic regression there is one parameter. Let me expand this. So there is one parameter in logistic regression called as max item, which is by default 100. It's by default 100. So what happens is because it is 100, the output is not converged easily because this all works on the principle of regression. Because not when regression, there are several number of iterations that take place when we do this. And so whenever we perform number of iterations, this answer it tends to converge. I don't have a pen and paper through which I can explain you how it converges, but uh, consider the movement of my mouse. So if for the first iteration I get my answer somewhere over here, in the second iteration somewhere over here, in the third iteration somewhere over here, in fourth iteration somewhere over here. So it keeps on, if I plot iteration versus my output, it keeps on moving like this. It keeps on moving like this. And the answer somehow converges in this manner. Converges in this manner. And you know, after some point of time, the answer, the output will not change with the change in number of iterations. That's when we say that our output has been converged. And in order for us to converge the output, the number of iterations that will be needed is usually a bigger number. So by default, the maximum iterations is 100 over here. You can see where's max iter. Okay. So, so max iter over here is 100. Right. What we'll do is we'll set this maximum iterations to a bigger number. So max iter, let's say somewhere around 30,000 or a bigger number. That's it, a bigger number. And let's create a object. Now, since we have created the object, let's model this. lr.fit. lr.fit. Now we'll train our data, train our model with our training data set. So which is xstring comma white. We have provided the training data set to it, and you can see that it creates a model. So this is the model that has been created. Now is this is the model that will help us predict the value. So lr dot predict. If I run this, now I will not give him now I will not give this model the testing data set or the testing outputs. I'll just give him the questions, the inputs, and I will ask him for the outputs. I'll say these are the outputs that this gives. These are the outputs that this model has given. Let me call this the predictions. So let me write it as threads because these are all predictions. And now we can say that our model has been trained. All right, our model has been trained. Now let's see how much, how is the performance. Let's evaluate the performance of our data set. So LR dot score. Let's see how it performs in the training part. So X train, comma Y train. We can see that it has performed not so good. It has performed only 51%. So let's multiply this by 100. Here that is, it's training score in percentages. So that is 51.61 percentage, which is pretty bad. We usually do not desire such kind of, training scores or testing scores. Let's see how it has performed in the testing. Multiply by 100. 48.49 or 4.4. So usually, again, we'll say that this is not the desirable output. So we can pretty much be sure that logistic regression is definitely not the good model for this. We would have to either try a different model for this, or maybe we will have to try the data pre-processing step once again. So what we'll do is, let's try to solve this using what I can say, model. So let's try to solve this with k nearest neighbor. So from sklearn dot um, k neighbors, or I guess only neighbors. So sklearn dot neighbors import and k neighbors classify. So k neighbors classify. All right. So let me create KNC, which is a k neighbors classifier model, and also need to specify the number of neighbors. Let's start with, or let's give it 11 neighbors. Alright, now we repeat the same process again and again. The same process of fitting and transforming. But transforming, but predicting this time. So knc dot fit x train comma y train. You'll see that the model has been created over here. This is a lazy learner, so it won't take any efforts while training. It will take a lot of time while predicting, but because it is a lazy learner, it works at the time of test. So, alright, so let's name it, or before naming it, what we'll do, let's check the scores first. So, KNC score is for X train, comma Y train. So this has given us a bit better score. KNC score, it has given us 62.5% of the score, which is better than what it did with logistic regression. And KNC score X test comma Y test. Testing score, however, is still low, 49.5. 49.5 is not a very good score. It's probably maybe because of the number of neighbors. If I increase the number of neighbors, possibly it might give us good result. But let's see. I've run all the cells. Still not so good result. So okay, so it's not giving good result in k nearest neighbor as well. So let's once again try to do it with random forest, because usually random forest works the best whenever we have to work on models. So scalar dot again, because it's what do I say, it's random forest. We have to load it from the ensemble module. We have to import random forest classifier. Right? So let me create instance of our random forest classifier as RFC, so random forest classifier, and we have to input such several parameters over here, but the most important is the number of estimators. So for now, let's keep it the way it is, 100 estimators. We will try to optimize it later. Now let's create a model. RFC equals to RFC dot fit. Let's fit it with X train, comma Y train. The model has been fit. Just a second. It's fit now. Let's check the training scores now. That's RFC dot score X train, comma Y train. So you see the training score is 1, which means it is perfectly, classifying it in the training data set. Perfectly classifying the classes in the training data set. Let us see the testing score again. So score X test, comma Y test. So this score is, but this score is again not so good. So this happens because there is one thing that is happening over here. So whenever the data tries or works best in the training data set but does not works good in the testing data set, such kind of errors is called as variance. This occurs because of overfitting. This occurs because of overfitting. Such this the sole reason for this should be there are several attributes or features in our data set which are causing this to happen, which are causing this to happen. So possible that there are several um, what you can say points in our data set that are not what you can say not related to our data set and still they are present in our data set. So there should be maybe there's multicollinearity or some kind of stuff that is hampering this scores. Let's see and let's try to optimize this with n number of estimators to be 200. Let's see if that works. Mm, Let's try to fit the model. So again, it's not increasing that much. So let's see. This issue is of the data again. So df dot head. Let's see the data once again. So this is the data again. Now let's see. Let's try to draw the heat map. So SNS dot heat map. We'll see how these are correlated to each other. df dot core numeric only. Okay. Okay, so one thing, let's also visualize the annotations. So okay, so you can see this is my output variable, it's fraudulent. And all the relations of this variable, all the relations of this variable with every other variable you can say is near to zero. Is near to zero. So there is no correlation of all these variables with our data or what our output data. So there is no relation of any other input variable with our data, and that's why it fails in our major assumption that our target variable should be linearly related to the input variable. No there is no such variable, no such input variable that is linearly related to the target variable, and that's why it's very tough or it's near to impossible to predict our target using such kind of variables. And that's why the prediction percentage came out to be around 0.49, 50% in any of the, what I can say, in any of the prediction models. We used three models. In all three, the testing score was near about the same. It was around 0.49 to 47 to 49%. So such kind of analysis and such kind of predictions is not accepted in the industry, and hence um, we can say that this is not a very good way to perform the, what I can say, the prediction model with. One thing that we might have overlooked is because we dropped a few columns before. Such as transaction time and transaction description. I'm pretty sure that description and transaction ID have nothing to do with it. But it's possible that transaction time would help us, you know, would help us predict if it's fraudulent or not. But for that, we will have to perform some different kind of analysis called as time series analysis. All right, and time series analysis is some advanced part in machine learning, which you won't be able to finish in an hour or so. It takes time to perform time series analysis. All right, so it's safe to assume for now because of this data. In this data, there is nothing or no such variable, no such input variable that can predict whether the whether it is a fraudulent transaction or not. And that's why we can say from here that we need to work more on it. The conclusion from this is we need to find a data set that will actually find some kind of relation of is fraudulent with the input variable. The target and the input variable should be linearly related to each other. And also there should not be multiple collinearity between the input variables. So over here, they do satisfy that they are not related to each other, but they are also not linearly related to the target variable as well, and which is the reason for the failure of this prediction. All right, so we are almost out of time for this YouTube live, and so I hope you got to learn something new from this YouTube live, and you got to you know learn how to work on a machine learning model. You saw how we applied various steps. We imported the discrepancies. We stated a problem. First of all, we stated the problem that we need to predict, or we need to create a machine learning model that would predict the fraudulent transaction. We went online, collected the data, and performed the ED on that data. We cleaned that data. We didn't do cleaning as much because it was already clean data. But later on, we moved to the data pre-processing step. We pre-processed the data for our machine learning modeling, and we, on the way we dropped a few columns. We, scaled the data sets or scaled the columns to the scalable ranges and stuff like that. And then we moved on again to splitting the data set and what can I say. We also converted the categorical variables. Then we labeled the data and split the data in training and testing data sets. Then what did next is we selected the model. Again, the steps from here are repetitive. We did this for three different models. For the first model, we imported we selected the model, we trained the model, we tested the model, and then we evaluated the model. And we repeated this step for all the three models. Now, if these models would have had been successful in this process, so expecting somewhere around 80 to 90% of the accuracy in classifying, if that would have happened, we would have said that we are happy with this model and we can use this model in actual world or actual project. The step of doing that is called as model deployment. So once we find our model to be good and making predictions accurately, we can deploy this model in an actual environment, in the production environment. All right. So this is the complete process of performing a machine learning problem, and I hope you got to learn something new or something interesting from this video, from this YouTube live, and I expect you to attend such lives again and again. We keep on doing this lives every Saturday, and you get to learn new stuff, new things every Saturday. We usually have various topics that we speak on. All right, so I hope you enjoyed this video, and if you enjoyed this, do subscribe to the channel, and I'll see you in the next live. But until then, I'll thank you all for coming to this video and being patient. Thank you.